I'd like to show you a simple procedure for graphing nonlinear equations and just kind of a reminder about how linear and then nonlinear equations are going to look. So for the linear equations, we are used to seeing the slope-intercept form y is equal to mx plus b. And again, that is for our linear equation, our straight line. And when we write this as a function, we will usually write it as f of x is the y value, and instead of writing m for the slope, we write a because of the format that we're going to be using for polynomials where the coefficients are a, b, and c. But in any case, any equation which does not have this format is then nonlinear, and there is a wide variety of nonlinear types of equations. Some examples that we see here are polynomials where the degree is greater than 1, that means second or third degree, and so on. So again, greater than first degree. So that's one type of example, a polynomial like this x cubed plus 1. Absolute value functions are also nonlinear, and so we've got here f of x is equal to the absolute value. And this rational function, which means that there is a fraction or a ratio, and in this case we've got 1 divided by x, and we sometimes call this particular function the reciprocal function. And so we're going to show you how to graph a couple of these functions. And when functions are linear, like this one up here, f of x, which is the y, is equal to mx plus b, we know that it's going to be a straight line. But for other types of functions that don't fall into this format, we are not necessarily able to predict what it's going to look like. And so one of the simplest ways to find the graph is just to plot points. This is not necessarily the most efficient way, but if you don't know where to start, it's as good a way as any. And so we're going to start by just picking some values of x and then calculating the y values that go with those. And when I don't know any better, I usually like to pick some negative values and some positive values, ones that are simple. So I'm going to start over here with x is equal to -2, and then x is equal to -1. Then choose x is equal to 0, and then +1 and +2. So now when I calculate the f of x or the y values, I'll just plug in those values and do the calculation. So x cubed is going to be -2 raised to the third power plus 1. And because it is a third power, the negative sign raised to a third power is going to give us a negative number, but then 2 raised to the third is a -8, and then plus 1. And so the value, the f of x value, comes out to be a -7. And we can do the same thing when x is equal to -1, raise that to the third power, plus 1. And so -1 to the third is equal to a -1, and we add 1 to that, and we end up with the f of x, or the y value, is equal to 0. When we plug in x is equal to 0, we get 0 cubed, and that's equal to 0 plus 1, and so that value is equal to 1. When x is equal to +1, we cube that and add 1, and that gives us 2. And finally, when x is equal to 2, we've got 2 raised to the third power plus 1, so that comes out to be a +8 plus 1. And then the y value for x is equal to 2 is equal to 9. So we have these listed as x and f of x, and we can think of the f of x as being the y value, so we'll put that on the y-axis. And now we can consider these to be ordered pairs and plot them. So when x is equal to -2, the f of x or y is equal to -7. So I'll put a dot there. When x is equal to -1, the f of x or y is equal to 0. When x is equal to 0, f of x is equal to +1. When x is equal to +1, the y or f of x is equal to +2. And finally, when x is equal to +2, the y or f of x value is equal to 9. We can see that going from the first dot to the second, that this is going to be a very steep line, and as we go from the second point to the third, it's a much more gradual slope, and then it becomes steep again. And so we can draw this as a curve, and the curve comes out somewhat S-shaped with the steepest portion on the ends and the flatter portion towards the middle. Depending on the degree of the polynomial, the shape of the curve is going to vary. I'll leave the absolute value function for you to graph, which you can do the same way by plotting points. Let's take a look at the reciprocal function. F of x is equal to 1 over x, and we can calculate the various y or f of x values by plugging in different values of x. And again, if I don't know any better, I can always pick my good old standbys when x is equal to -2 and -1 and 0, +1 and +2. So I'm going to do the calculation of f of x. So the y or f of x is equal to 1 divided by x, which is 1 divided by -2, and that's equal to -1/2. When x is equal to a -1, I get 1 divided by a -1, and that's equal to a -1. But when I plug in x is equal to 0, I get 1 divided by 0, which gives me something undefined, and so that's a number that I can't use. So I'm just going to put a line there that that number we might say is infinity, but infinity is not a real number. When x is equal to 1, f of x is equal to 1 divided by 1, and that is also equal to a +1. And when x is equal to 2, I get f of x is 1 divided by +2, which is just going to give us a half. So we actually get 4 points that we can plot. The first one is the point -2, -1/2, so x is -2 and y is -1/2, and we can put a point there. When x is equal to -1, y is also equal to -1, so we can put a point there. When x is equal to 0, we don't have any point that we can plot, but we also have the point +1, +1, and finally we have the point when x is equal to 2, y is equal to +1/2. Now, that doesn't give us a whole lot of information. We can see it looks like there's two pieces here, maybe a line that goes like this and another line that goes like this. But one thing we have to remember that as a function, the vertical line test requires that our portions of our graph don't lie on top of each other. So we can't extend this line too far, or it will actually run into the same x values as the points that are over here. So I really need to get more information on how this graph is going to look. So I'm going to just plot some more points. If I let x equal to +3, then I calculate the value. The f of x value is 1 divided by a +3, which is 1/3. And so when we go over here, x is equal to 3 and y is equal to 1/3, we can see that this gets even closer to the axis. And as we go further and further out, we're expecting that this fraction is going to get smaller and smaller. So we are expecting this to get close to the axis, but never actually to touch it. Now, the interesting part of this graph is going to happen as we get closer and closer to x equals 0, but not actually equal to x equals 0, because that does not give a defined point. But if we were to pick a smaller number than a half over here, or a smaller number than 1 over here for, say, x is equal to a half, let's see what happens. So when I let x equal to be +1/2, then my f of x, which is 1 over x, is going to be 1 divided by a half. And that's going to give me a +2. And so I've got the point a half, when x is equal to half, the y, or f of x, is equal to +2. And as these fractions get smaller and smaller, for example, when x is equal to 1/3, we're going to take the reciprocal of that, and then the f of x or y value becomes 3. And so as we get closer and closer to the y-axis, as x gets smaller and smaller, these y values are going to increase. And we get a curve that looks something like this. We can do the same thing for some negative values of x. For example, if we were to choose x is equal to a negative 3, then when we calculate the reciprocal, 1 divided by negative 3 gives us negative 1 over 3, or negative a third. And so we would have the point when x is equal to negative 3 that the f of x or y value is negative a third. And again, you can see we are going to get closer and closer to this x-axis without actually touching it. If we want to see what's happening in this area, we want to choose values of x that are negative but are between 0 and 1, 0 and negative 1, and so we would choose something like negative a half. And when we take the reciprocal of that, 1 divided by a negative a half, that's going to give us a negative 2. And so we would get here, when x is negative a half, y is equal to negative 3. And we could continue plotting points in this way as well. When x is equal to negative 1/3, y is equal to a negative 3, and so on. If we go and draw the graph, it's going to look like this. So now we've got a fairly complete picture of what the reciprocal function looks like. We could extend these out to infinity in either direction, but this is the shape that we're going to see for this type of function.